Hey everyone, and welcome. Today we are going on a grand tour of our solar system. We're talking everything from the fiery red plains of Mars to the icy giants spinning out there in the darkness. We'll explore planets, moons, and all the other strange celestial objects that make up our cosmic neighborhood. So let's jump right in. So here's our game plan for today. We're going to kick things off with our closest neighbors, that's Mars and the gas giants, before we zoom in for a closer look at Earth's constant companion, the Moon. From there, we'll journey to the outer reaches to meet the dwarf planets, get you up to speed on some incredible recent missions, and then we'll wrap up by breaking down a few key cosmic terms you should know. All right, our first stop is a real planetary showcase. We're starting with the world that has captured our imagination for centuries, the red planet, before we head outward to the colossal gas giants that totally rule the outer solar system. And here we are, our first destination, Mars. You've probably heard it called the Red Planet, and that famous nickname comes from all the iron oxide, basically rust, that covers its surface, giving it that really distinct reddish color. It's actually the second smallest planet in our solar system, and it's got these two little potato-shaped moons tagging along, Phobos and Deimos. And get this, Mars has some absolutely incredible features. It's home to Olympus Mons, which is a shield volcano so massive it's nearly 3 times the height of Mount Everest. That makes it, by far, the tallest mountain in our entire solar system. A day on Mars feels surprisingly familiar, lasting just a little over 24.5 hours. And just beyond Mars, you'll find the main asteroid belt, a huge ring of space rock where NASA's OSIRIS-REx mission just recently paid a visit to the asteroid Bennu. Okay, now we've arrived at the undisputed king of our solar system, Jupiter. I mean, this gas giant is so massive that you could fit all the other planets inside it. And, despite its enormous size, it spins faster than any other planet, completing a full rotation in under 10 hours. That incredible speed is what creates its famous, distinctive bands of clouds.
If you look up at the night sky, Jupiter is often the third brightest thing you can see, only outshone by our Moon and Venus. It's got this huge system of at least 95 moons. The 4 most famous are the Galilean moons, that's Io, Europa, Ganymede, and Callisto. And Ganymede is a giant in its own right. It's the largest moon in the entire solar system, even bigger than the planet Mercury. And of course, you can't talk about Jupiter without mentioning its most famous feature, the Great Red Spot, a colossal storm that has been raging for centuries.
Next up, we're visiting the jewel of the solar system, Saturn. Now, it's the second largest planet, but what really defines Saturn is its absolutely breathtaking ring system. You see, these aren't solid bands. They're actually made of billions of individual particles of ice and rock, each one in its own orbit, forming this spectacular, shimmering disk. But Saturn has secrets way beyond its rings. It has the lowest density of any planet in the solar system. In fact, it's less dense than water. So what does that mean? It means if you could find an ocean big enough, Saturn would actually float. It's also surrounded by a staggering number of moons. We're talking over 140 confirmed so far. The largest one, Titan, is a whole other world with its own thick atmosphere. And even more exciting, both Titan and the icy moon Enceladus are considered top candidates in the search for life, because we know they have liquid water and organic materials. You know, for centuries, astronomers have just been captivated by these rings. It was Christian Huygens who first correctly figured out what they were, way back in 1655. And then, just 10 years later, Giovanni Cassini noticed a really distinct gap within the rings, a feature we now call the Cassini division. Okay, continuing our journey out into the cold, distant parts of the solar system, we arrive at the ice giant Uranus. And that peaceful blue-green color you see? It isn't from water, it's from methane gas in its atmosphere, which absorbs red light and reflects the blue and green light back at us. Uranus was discovered by William Herschel back in 1781, and it is a strange and tilted world. Its atmosphere is a super cold mix of hydrogen, helium, and icy stuff like water and ammonia. But what really makes Uranus stand out is its bizarre orientation. The planet is tilted over on its side at a 98-degree angle, so it's essentially rolling around the sun. This crazy tilt gives it the nickname the rolling planet and leads to some of the most extreme seasons you can imagine. Our final stop among the giant planets is the deep blue world of Neptune. It's the most distant planet from the sun, and its journey around it is just immense. It takes a staggering 165 Earth years to complete a single orbit. But even with that long year, its day is incredibly short, spinning on its axis in just 16 hours.
Neptune is truly a world of extremes. It's the windiest planet with supersonic storms just raging through its hydrogen and helium atmosphere. And that deep blue color? Just like Uranus, it comes from methane. But what's really amazing is how we found it. Discovered in 1846, Neptune wasn't just spotted by chance. Astronomers noticed Uranus was being pulled by the gravity of something they couldn't see, and they used math to predict exactly where to point their telescopes. Just an incredible triumph of science.
All right, let's pull our focus back from the far reaches of the outer solar system and come back home for a bit to look at the most familiar object in our night sky, the moon. So, the moon is Earth's one and only natural satellite. And you know, it might seem like it glows all on its own, but it's really just a giant mirror. The beautiful moonlight we see is just the sun's light bouncing off its dusty, cratered surface. Let's just run through some numbers. The moon is about 384,000 kilometers away. That means the light you see from it tonight left just 1.26 seconds ago. Pretty cool, right? And if you could stand on its surface, you'd feel incredibly light. Its gravity is only about 1/6 of what we feel here on Earth. And just like Earth, it has mountains, with its highest point, known as Mons Huygens, rising high above the lunar plains. You ever wonder why you always see the same man in the moon and never the back of his head? Well, it's because from Earth, we only ever see one side of the moon. This happens because of something called tidal locking. Basically, the moon rotates on its axis at the exact same speed that it revolves around the Earth, which keeps one face permanently turned towards us.
Okay, let's head back out to the colder, darker parts of our solar system and talk about the objects that didn't quite make the cut to be a planet, the dwarf planets.
So, what exactly is a dwarf planet? Well, to qualify, a celestial body needs to check 3 boxes. First, it has to orbit the sun. That's a given. Second, it needs to have enough gravity to pull itself into a nearly round shape. But this third rule is the real deal-breaker for becoming a planet. It hasn't cleared its orbital path of all the other asteroids and debris.
And the place most of these dwarf planets call home is a huge icy region called the Kuiper Belt. A good way to think of it is like a second, much larger asteroid belt that starts just beyond Neptune's orbit. It's filled with countless icy bodies, rocks, and frozen leftovers from when the solar system was forming.
And this, of course, brings us to the most famous resident of the Kuiper Belt, Pluto. I'm sure a lot of us remember when, back in 2006, Pluto was dropped from the list of planets. Well, Pluto is now officially classified as a dwarf planet and a proud member of the Kuiper Belt.
Pluto isn't alone out there either. It has 5 of its own moons, and the largest one, Charon, is so big that the two are often called a double planet system. Pluto's year is incredibly long. It takes 248 Earth years just to make one trip around the sun. Its orbit is also really elliptical, and it even swings inside Neptune's path from time to time. And hey, despite the reclassification, Pluto still holds the title of the largest and brightest known dwarf planet in our solar system.
And Pluto has a lot of company out there. There's Eris, a distant world that's almost Pluto's size. Then you have Makemake and the super fast-spinning, oddly shaped Haumea. All of them are out in the Kuiper Belt. But one dwarf planet is much closer to home, Ceres, which is the largest object in the main asteroid belt between Mars and Jupiter.
You know, our tour isn't just about what we already know, it's also about what we're actively exploring right now. So let's look at a couple of really exciting recent missions from India's space agency, ISRO, that are pushing the frontiers of space science.
First up, the Aditya L1 mission. This is India's first dedicated solar observatory. It's parked at L1, which is a special spot in space called a Lagrange point, where the gravity of the Sun and Earth perfectly balance each other out. This lets the spacecraft just hang out there in a stable position. Then there's the truly historic Chandrayaan-3 mission. Its lander, Vikram, and rover Pragyan successfully touched down near the lunar South Pole, a massive achievement, at a landing site that's now named Shiv Shakti Point.
All right, to wrap up our journey, let's quickly break down a few key cosmic terms you'll hear all the time. This way you'll have a better handle on these incredible space phenomena.
Let's run through these real quick. A supernova is the massive cataclysmic explosion of a star at the end of its life, and for a short time, it can outshine an entire galaxy. A pulsar is the super-dense, rapidly spinning core left behind after a supernova, and it sweeps beams of radiation across space like a cosmic lighthouse. A black hole is a place in space with gravity so intense that nothing, not even light, can escape. And then, a little closer to home, the Van Allen belts are 2 donut-shaped rings of charged particles that are trapped by Earth's magnetic field.
And that brings our tour of the solar system and beyond to a close. We've covered a ton of ground, from our rocky neighbors to the icy outer reaches, all the way to the frontiers of human exploration. And that leaves us with one final thought to ponder. As we learn more about these distant moons like Saturn's Titan and Enceladus, which show real possibility for life, what do you think is the most likely form of life we might actually find out there?